Hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet with me, Richard here. Yes, today we are looking at this question. It says that state Avogadro'S law of gases. Okay, so how do we state this? Okay, this states that equal volume of all gases at the same conditions of temperature and pressure contain the same number of moles or contain the same number of molecules. Or you can state it as follows, that 1 mole of any gas at the same conditions of temperature and pressure occupy the same volume. Yeah, that's that. Then we come to this one. It says that write STP in full. So what is STP in full? STP stands for standard temperature and pressure. Yeah, so we come to this one. It says that identify the conditions designated as standard temperature. Yeah, what condition is designated as standard temperature? Standard temperature is 0 degrees Celsius or 273 Kelvin. Yeah, then we come to this one. The conditions designated as standard pressure. What is it? It is 1 atmosphere or 1 or 1.3 kilopascals. Yeah, then we come to this question. It says that consider the following gases. Okay, we have A, which is 2 grams of carbon dioxide, and you have B, which is 5 kilograms of oxygen. And they say calculate 1, the number of moles of each, and 2, the volume occupied by each at STP, or standard temperature and pressure. Okay, to establish a perfect relationship between these two questions, we are going to consider one gas at a go. Okay, let us look at 2 grams of carbon dioxide first. Okay, so if you look at question 1, the number of moles of the gas, here we have the mass and we're looking for moles, and we know the relationship. What is it? It is N, standing for number of moles, equals to mass over molar mass. Okay. Yeah, but do we know N? No, it's what we are looking for. But we know mass. Mass is 2 grams. What else do we know? We know the molar mass because we know the gas we are dealing with is carbon dioxide. So for carbon dioxide, what do we know? We know carbon is 4. We know carbon is 12. Then plus 16 for oxygen, but times 2. This one will give you So what is the next step? Next step is to substitute. Okay, we are calculating N, but we know mass, which is 2, and the molar mass, which is 44, giving us. Yeah, so now we have the number of moles of carbon dioxide. What do? We go to the question number 2, the volume occupied by the gas at STP. That volume is established by Avogadro. It's going to be that volume was established by Avogadro. It says that number of moles equals to volume over molar volume at that very temperature. Okay, number of moles is known. We calculated it already. It's 0.045 moles. And this is the volume we are calculating. We don't know it, but we know molar volume at STP, which is 22.4 cubic decimeter. It's a constant. So what do? We substitute. Okay. In this case, our N is 0.045. And the volume we're calculating is there. But we know the molar volume, which is 22.4. And how do you go about this? You cross multiply. You get V equals to 0.045 times 22.4, giving us, that is it. So we have it here as 1.02 cubic decimeter. Then we come to this one, 5 kilograms of oxygen. Okay, if you look at the first one, which looks for number of moles, here we have the mass, and the mass is 5 kilograms, which is the same as 5,000 grams. Okay, and you're looking for number of moles. We don't know it, but we know the molar mass of oxygen gas molecule, which is going to be 16 times 2, giving you 32. So from here, what do? You substitute in the equation, which says N is equal to mass over molar mass. Okay, and what is N? N is wanted, but mass is 5,000. And molar mass is 32, giving us, we have now the number of moles. What is our next step? Our next step is to go to the second part. They want volume occupied by the gas at STP. Now, that question is done by using the relationship which says that number of moles is equal to volume of the gas over molar volume at that very temperature. So for this case, what is N? We know our N. It is 156.25 moles. What else do we know? We are looking for this. We don't know it, but we know the molar volume. The conditions are standard temperature and pressure. So the molar volume at standard temperature and pressure is known. It's 22.4 cubic decimeter. Is a constant. So what do we do here? We substitute. Okay. N is 156.25. Okay. the volume wanted is there, but the molar volume is 22.4 cubic decimeter. So from here, what do? We cross multiply. You get 156.25 times 22.4, giving us, so this is it. 3,500 cubic decimeter. Now we come to this question. It says that consider the decomposition of calcium carbonate as indicated in the equation below. This is the equation for the decomposition of calcium carbonate. It decomposes to give us calcium oxide and carbon dioxide. And the question says that calculate the volume of carbon dioxide released when 2 grams of calcium carbonate is decomposed completely. Okay. So how do you go about this? Okay, the first step is to identify the parts of the equation we are going to make use of. The part of the equation which we are going to make use of. Okay, first of all, we are given mass of calcium carbonate. So we are going to make use of that. And we are looking for carbon dioxide released. So we are going to use this. So those are the parts of the equation we are going to use. Our next step is to look for the ratios. The number here is 1 and the number here is 1, implying that 1 mole of calcium carbonate decomposes to give 1 mole of carbon dioxide. Actually, we can put that one down and we say that 1 mole of calcium carbonate decompose to give 1 mole of carbon dioxide. Okay. Yes, but we don't have mole. Here we have the mass of calcium carbonate. So what do we do? After establishing this, we can say calculating number of moles of calcium carbonate. Yes. So if you are calculating number of moles, it's N. We are looking for it. But we know the mass. The mass is 2 grams. And we know the molar mass of calcium carbonate by virtue of knowing the chemical formula. Calcium is 40 plus carbon, which is 12, plus oxygen, which is 16 times 3, giving us. So with this information, what do? We substitute. We have N is equal to M over molar mass. And mass is 2 grams. And molar mass is 100, giving us 0.02 moles. Okay. Yeah, now that we know number of moles, we can go back to our ratios. Remember, we are looking at calcium carbonate to carbon dioxide, and we found the ratio as 1:1. But we have just calculated the number of moles of calcium carbonate, which is 0.02, implying that even the number of moles of carbon dioxide is 0.02 by virtue of the ratio being 1:1. So now we know number of moles of carbon dioxide, and it is 0.02. And we know the molar volume at STP, and it is 22.4 cubic decimeter. And we are looking for V. So what do we do? Yes, we substitute in our equation. The equation says that N is equal to V over Vm. So, which means that 0.02 is equal to volume, which is required, over 22.4. And how do you go out of this? By cross multiplying. You're going to have 0.02 times 22.4 equals to V. So our volume is going to be, that is it. So our volume of carbon dioxide released is 0.448 cubic decimeter. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, with me, Richard, here. We urge you to subscribe, to comment, to like, to share. Yes, we believe we are the best. See you next time. Bye-bye.